Okay, thank you for joining us. Today we're going to be presenting our Campus Mobility Engineering Design Project. To get us started with a quick team introduction for Team 21, I'm Elliot.
I'm Quinn.
I'm Arnav.
And I'm Kevin.
All right, to start off with the problem statement, which consists of the clients and users, the clients being the College of Engineering and the Facility Affairs Committee, while the users are the pedestrians, bikers, skateboarders, and drivers. And the need is we want to improve safety of the Russell intersection overall. And the problem is there's just too many dangers and safety issues. So we hope to innovate a solution to improve safety in this area. And this problem is important to solve because we want to improve campus safety and the intersection efficiency overall. The criteria and constraints, the criteria are it's desirable, effective, economically viable, and technically feasible, while the only constraint is that it uses microcontrollers. And lastly, we have the metrics, which are additional required implementation space, maintains environmental aesthetic, likelihood to improve safety, cost of basic materials, estimated timeline to acquire materials, and estimated time of implementation.
Next up, we have the summary of our alternative solutions. The first solution is the paired alarm system, which sounds an alarm every time a pedestrian tries to jaywalk. The second one is the crossing for disabled individuals, which allows disabled individuals to have an extended crossing time. And the third one is the color or pattern changing crosswalk, which basically provides visual tactical stimuli in order to incentivize people to not jaywalk. We put these three solutions in a weighted decision matrix with the criteria and metrics listed by Quinn before. And after the weighted benchmarking, the disabled crosswalk system came out as our top choice. And we decided to go ahead and pursue that as our final solution.
So here on the screen, we have a diagram of our final solution. Now with a normal crosswalk, you simply activate the button, the crosswalk timer turns on, and when the timer's off, you can't cross anymore. So instead of a button, we had to use an ultrasonic sensor because a button was included in the TI kit. So for our final prototype, what we have is a disabled pass scanner on the left-hand side of the screen over there. And when someone who has a disabled pass scanner, they scan the scanner, it sends a signal to the microcontroller base, which then sends it over the crosswalk timer, and it'll increase the crosswalk time by an additional 10 to 20 seconds so that people with wheelchairs or other disabilities have extra time to cross. And here's just some data on why we chose our final solution. This data is also included in our matrix, but essentially we conducted a poll, and out of the three solutions we had, the disability crosswalk, as you can see from the graph, was polled to be the best solution out of the three.
Okay, and finally we have the trade-offs and limitations. With any engineering project, there's going to be a number of trade-offs we have to make, one of which is the fact that while it does have a high impact for a certain smaller population, that population is small when you take it in comparison to the whole population of users at Purdue. Additionally, while it's going to improve some user and pedestrian experience, it's going to impair some driver experience as well, just because of that longer crossing time. Additionally, there are some limitations for this project, one being the fact that physical passes will have to be made and distributed to disabled users on campus, and there's just another cyber upkeep component. Putting another cyber system in place to use on campus is going to limit Purdue's IT infrastructure. Finally, we also have our references that we use for the project, and that is it. Thank you so much for watching.